Now, earlier we have introduced this notion of entities, that is what we started off with, right, entities. Okay. And entity is something which is a which is something which we are concerned about. It is an important thing that we would like to model in the information system, and then entities had attributes and then they participate in relationships, etc. Now, in practice we also encounter a slightly different kind of entities. So, these are called weak entities. The difference between this and the entities that we have been discussing so far, which now can be actually called as strong entities, is that the existence as far as this information system is concerned, the existence of these entities in this weak entity set, depends on the existence of some other entity. Unless that entity exists, there is no point talking about this entity which is a which we are calling it as a weak entity. So, these weak entities are not of independent existence, their existence is owed to the existence of some other entity, possibly in a strong entity set. Okay. So, each of these weak entities is associated with some entity of we call them as the owner entities, through a special relationship. Okay. Now, when we discuss examples, it will become very clear, but basically what we are saying is that there are certain kind of entities whose dependence, whose existence in some sense depends on the existence of other entities, and we call the other entities as a owner entity. Because the owner entity exists, this other entity which we are calling as weak entity becomes important for us. Now, so let me give you an example, we will see couple of examples. So, the weak entity set may actually not have a key attribute at all. It may have what is called a partial key, we will talk about it, and the owner entity might itself be a weak entity. Okay. It is possible that the owner entity, what is a owner entity? A owner entity is something which kind of owns this weak entity. That itself can be weak, in which case there is a chain of these weak entities, and so ultimately of course it has to be owned by some strong entity. Now, okay, here is the diagrammatic notation for that. So, the weak entity is shown with a double wall box. We used to use normal rectangular boxes earlier for entities. Now, weak entity will be shown with a double wall box, and the name of the weak entity will be written here, and there is always a special relationship that connects this weak entity to the owner entity. Okay. So, this kind of this relationship is also called the identifying relationship, and this weak entity always participates totally in this identifying relationship, okay, because this weak entity cannot exist unless it is related to some strong entity, owner entity. So, this kind of situations arise, and in order to capture their meaning in the domain, we like to we use this notion or concept of weak entities. So, let me give you an example. Let us say a popular course is there. Nowadays one of the popular courses is machine learning, right. So, you offer multiple sections of the machine learning, people will enroll for that. I hear that enrollment for machine learning crosses 100 or something like that. Okay. So, let us say there is some popular course, and so we decide to have sections for the course. So, what is a section? A section is an offering of that course, and that is where actually students enroll into these sections. Each section is taught by a professor, maybe a different professor. If you have multiple sections, A, B, C, D, A, B, C sections, each of them is taught by a different professor, and each of it has its own classroom and meeting times, right. So, it has all these things, and it is students enroll for these sections, right. Now, but you can see that why section is a weak entity is that unless the course exists, the question of having a section does not arise, right. So, we have a course and it is popular, and so we would like to, and even otherwise whenever a course is being offered in multiple years and things like that, we can always call it an edition of the course, right. So, for the 2019 database systems course, you are all kind of enrolled into. So, this edition exists because the course exists, right. Course is a strong entity and section is a weak entity. Sometimes, so there will be multiple sections associated with the course, and so we model this as a weak entity, mainly because it owes its existence to the existence of the strong entity called the this database systems course, or whatever course it is. And we call this has section relation as the identifying relation, and this is called a weak entity, and this is called its corresponding owner entity, and we show the arrangement like this. Now, the sections, all sections corresponding to one particular course, like CS 1100, like the introduction to computing, there are usually 4 sections for that course, right. So, we have to identify those sections. Is this section A, section B, section C, and so section D. So, we give some section number 1, 2, 3 or some letter A, B, C, D, and that will be identifying the actual sections of that particular course. So, such a thing, an attribute like section number or section name, section letter or something like that, which has this property that it will identify the exact section among the sections that are associated with a particular course, is what we are calling as a partial key. It is not a key, because if you just consider all possible sections being offered by the department and then say that okay, this student is enrolled in section A, when it does not make sense, right. What section A are you talking about? CS 110 has section A, machine learning also has a section A, and something else also has a section A. So, what section A are you talking about? So, the section A by itself does not identify any particular section, and so that is why it is called a partial key. So, the course, whatever the course ID along with this section number together only actually identifies the section uniquely, okay, because all these sections are associated with that course. So, the course ID or whatever is the key for that particular strong the owner entity along with this the partial entity will uniquely identify this particular section. In general, that is how it is. So, it might have some attribute which might act like a key, but it is not necessary that weak entities have a key. That is the point we are trying to make. In the book by Professor Elmastry and Abate, they give an example of dependents of an employee. So, the organization is interested in keeping track of the information about the dependents of employees as long as the employee exists in their organization. If that particular person leaves the organization, then there is no point keeping track of the information about his or her dependents. So, the dependents of a particular employee are best modeled as weak entities in that organization, because they are basically interested in those dependents because they have hired that particular employee, right. So, those are dependents will become weak entities owned by the corresponding employee. So, now in this case you can see that those dependents are anyway persons, and so they might actually have some identifying attribute like social security number or Aadhaar number or something like that, which is an identifying attribute, right. It is a key attribute, I mean it identifies the person uniquely. But that's besides the point, that as far as the information system is concerned, it is not necessary that all these weak entities that we may be interested in may have a key. So, but what we are guaranteed is that we should introduce some attribute which can uniquely identify all the sections or all the weak entities associated with that strong entity, and usually we can find such a attribute, and that is what we call as a partial key. Okay. So, is this idea of a weak entity clear? Essentially it is we are saying that there are situations where we like to keep track of certain entities, but only thing is that the existence of those entities depends on the existence of some other entities which we are interested in. Now, let me give another example. The institute has many pieces of equipment which are used for scientific experimentations and things like that, and we would like to keep track of their utilization, who is using it and when they are using it and things like that. So, usage of a particular equipment is best modeled as a weak entity. Unless the equipment exists, there is no point talking about the usage of that equipment, right. The usage is modeled as a weak entity, and it is connected to the equipment strong entity, owner entity, through this identifying relationship called utility, and then it has its own attributes. What is the usage number? Something which uniquely identifies the usages of a particular equipment, and then who has used it, and which department that particular person belongs to, when was it used, date, time, and what are the charges. We may internally have some arrangement of charging the person for using that equipment, and things like that. So, again this is best modeled as a weak entity, and usage number serves as some partial key here, which will identify the usages of a particular equipment. Typically this kind of information will be maintained in a small register associated with that. So, you go to a photocopier, then they will say okay, you write your name and then use it, and they at least know that okay, it has been used, so many pages have been copied and things like that, right. Okay. So, with this the principal constructs that are available, the conceptual tools that are available in entity relationship model have been actually covered. So, let me summarize that. Basically the entity relationship model is a data model, that means it is a collection of conceptual tools to describe the database at the conceptual level, and it has these notions of entities, attributes for entities and various kinds of attributes, we have seen them, and relationship types and various kinds of one to one, one to many different kinds of relationships, binary relationships, and then the notion of weak entities. All these things together give us a bunch of tools to kind of capture the domain information and represent it in a diagram. So, I will what I will do next is to look at typical how we write down the collection, how do we write down the specifications in plain English, and then later actually translate that into a bigger diagram. entity ER model. So, this particular example is what I am going to use in later on also when we discuss relational data models, etc. So, let us go through that. So, many of these concepts have actually been introducing as examples as well as I am discussing these various notions. So, let us capture all of them together and put them at one place as a complete example. So, in an education institution there are several departments and each student belongs to one of them, and the department has a unique department number, a name and a location, phone number, and is headed by a professor. Professors have a unique employee ID and name and phone number, and professor works for exactly one department. This is how we can jot down the domain information, and so that we can later translate that into an ER diagram. Later on in an assignment, I would actually like you to do this kind of an exercise where you choose a domain and then jot down the main facts that you want to reflect in the domain model, and then actually translate that into an ER model and submit that. So, we like to keep track of the following details regarding students: name, the roll number, unique roll number, sex, phone number, date of birth, age, and one or more email addresses. Students have a local address consisting of hostel name and room number. They also have a home address consisting of home number, city, street pin. It is assumed that all students reside in hostels. Now, you might actually wonder if a particular attribute is not applicable for a particular entity, what should it be its value? Okay. We typically use what is called a null value for that. Okay. We will meet that again later on also. Okay. A course is taught in a semester of the year and is called a section. Okay. So, whatever courses are not directly taught, it is a section of the courses that are taught. So, when it is taught in a semester of the year, it is called a section. There can be several sections of the same course in a semester. These are identified by the section number, and each section is taught by a professor and has its own timings and a room to meet. Students enroll for several sections in a semester. In a given semester, students enroll for several sections, and each course has a name, number of credits, and the department that offers it. There is a owner department for it. A course may have other courses as prerequisites, that is the courses to be completed before this particular course can be enrolled in. And then professors also undertake research projects, and these are sponsored by the funding agencies and have a specific start date, end date, and amount of money given to them. And then more than one professor can be involved in a project. Also, a professor may be simultaneously working on several projects. A project has a unique project ID. So, this is how we gather together all the facts that we want to model, and then start putting them all together in a diagrammatic notation, the ER model notation, and then have discussions with the end users. So, here is how student entity is modeled. So, you have seen it already. So, let us just see that the name is just as per the writing there, we ignored that name has any other components, we just named it as name. Roll number is unique. So, we underline the key attribute, because it is its value can be used to uniquely identify the student entity. There are one or more email IDs, so it is a double this one ellipse. Then we have address. Address is a composite attribute because it has house number, street, city and pin. And the local address is also a composite attribute because it has a hostel name and room. We are interested in date of birth, and age is a derived attribute, and we are interested in the gender of the student. So, these are the various attributes. So, we typically draw it like this. Then we have the department. Department has a department number which is which serves as the key attribute, and it is headed by a professor. So, we call that, so we capture that through a HOD attribute, and then name of the department, location, phone number. Course entity, course ID, credits and name. So, recall that courses are offered by department. So, we intend to capture that as a relationship, because each of these things is a entity, department entity exists and course entity exists. So, later we will capture that the departments offer courses through a relationship. And then professor, name, ID, phone number and maybe email address, things like that. Okay, I am trying to strictly follow what was there given in that English text. And section is a weak entity, section ID, classroom and timings. Timing is multiple timing. So, it captures basically as to at what times of the week the section meets. We have project, which is having a sponsor and an amount of money given, and what is the start date, end date, and what is the ID of the project. Now, let us put all these things together into one diagram. This is how that. Now, only I want to remind you that because I am using slides, and the slide will get cluttered if I write all the attributes around this. I have not written here, but normally what you do is you do not show this ER diagram like this. You when you show the entity, you also show all the attributes around it. Likewise, if any relationships also have attributes, we have to show all of them. So, just because the slide will get cluttered, I have shown these entities separately, and I am now showing the relationships alone. So, ER diagram showing relationships alone, but normal ER diagrams will have all the attributes also written here. Okay, now let us focus on the various relationships that we have here. The student belongs to a department. So, it is a many to one this one relationship, many students belong to one department, and department offers several courses, department offers several courses. So, it is a one to many relationship, and professors work for department, binary relationship between professors and department works for, and many professors work for a single department, and each professor works for exactly one department. So, that is why it is one to many. And then professors work on projects. So, this we have also already discussed. This is a typical many to many relationship, because professors work on many projects, and each project can have several professors associated with that. So, it is a natural many to many relationship. So, that is why it is shown as M and N, and professors. Okay. So, now courses have sections. So, courses are not directly taught, it is the sections that are taught. So, section we have introduced as a weak entity earlier. So, that section has section ID, classroom and timing, right. So, and it is a weak entity owned by course, and this is the identifying relationship. So, professors teach sections and students enroll into sections. Okay, so there is an enrollment relationship which is a many to many relationship, because many students enroll into one section, and a student typically enrolls for many sections, and a professor teaches more than one course section. So it is a one to many. So all these are the relationships, and prerequisite is a relationship that exists between courses. So we should ideally write the role name here. I have not written the role name. Course participates as a course and as a prerequisite. So participates as a, in what role does it participate? As a participates as a prerequisite, participates as a course. So that is the prerequisite of relationship. We call this as recursive relationships in database parlance. Okay, so I hope it is now clear to you as to how you can construct this ER diagrams and then take them for discussions with the stakeholders, so that you can understand and the entire requirements, and we can also convey to them as to what we have understood about the domain, what we are going to represent in the domain. Later on they should not ask for something which we have not discussed, right, and then finalized, because all these design decisions are best made, data model requirements are best made at the design stages. Later on if they start asking for additional things, it becomes a little bit messy to handle the database system, when creating the database system. Okay. Now let me take you through in a tutorial. What we will do is to, so I want you to have the develop the skill of reading a ER diagram and understanding that, okay, and then write down in plain text about a particular domain and translate that into an ER model, or given any situational description, translate that into an ER model. So these two things are what you should aim for. So I will devise a few exercises like that, and then we will have a tutorial session sometime next week. Okay. So let us come to a few questions which we might which we will encounter as we are trying to develop these designs. One of them is attribute versus relationship. To give a concrete example, I mean this dilemma between attribute versus relationship. Should offering department be an attribute of a course, or should we create a relationship between course and department entities and call it offers? This is what actually we have done in the previous figure, but why should it be like that? Why can't we simply create an attribute for the course and call it offering department, and it will have a value, right? So then it indicates what is the offering department. So we will be done with that. Why should we go for a relationship? Now whenever the other entity, see for example, so what we are now talking about is for a particular entity like course, should some piece of information be modeled as an attribute or as a relationship? So this is again this is a design choice. If that information is actually corresponding to a particular entity that already exists, then the approach of creating a relationship is to be chosen, and if it does not, then you can go with an attribute. So that is the kind of choice that we have. So it is preferable if the for example in this case department exists as an other independent entity. So in this case it makes sense for us to create that relationship like offers and then put it, rather than making offers as a attribute of course, making offering department as an attribute of course. Instead we can actually show that the association between course and department through a relationship. Okay. If it is some other information which cannot naturally get linked up with any of these existing entities, then you choose the option of modeling it as an attribute basically. Now, another kind of choice, should classroom be is related situation is, should classroom be an attribute of a section, or should we create an entity called classrooms and then make a relationship saying meets in and then connect them to this also we can do actually. We can create an entity called classroom which is an entity set consisting of all classrooms, and then say that this particular section meets in a particular classroom. So, we can create a meets in relationship and then connect these two entities, that option exists. What we have done in this case, if you go back to the picture, is simply we made a classroom as an attribute. We did not model classrooms as entities, we simply captured that information as an attribute of section. Again, this is a design choice, and in our information system we are not keen on keeping track of lot of other information about classroom as to what is the equipment that is there in that particular classroom, who is in charge for upkeep of that classroom, and who has the keys, where the keys have been issued. Let us say we have our information system actually is supposed to keep track of that information also. If that is the case, then it kind of makes sense to model the classroom as an entity, because we have lot more other information to keep track of, and once that classroom becomes an entity, we can then create a meets in kind of relationship and connect up this section with that classroom entity. But since we do not want to, but in this particular specifications that we have, we are not keeping track of lot of other information about classroom, and so we have chosen the route of modeling it just as an attribute. Okay. So, these are some of the design choices that we will have to make when we construct the model. It all again depends on the domain knowledge that we are supposed to capture, okay, and the usage of that information. So, in this case the option of making a classroom as an attribute is better, as we do not want to give a lot of importance to the classroom and kind of make it as an entity, because we do not have additional, we are not required to keep track of additional information about classroom, okay, as per our specifications. Okay. So, this is one interesting point. Then let us look at this other situation, weak entity versus composite multi-valued attributes. Remember that we have attributes and multi-valued attributes. Multi-valued attributes are attributes that can take multiple values, right, a set of values, and then composite, that means they have components in that. So, for example, a section actually could also be modeled as a composite multi-valued attribute of a course. Do you realize that I can model a section, I have multiple sections. So, basically it is multi-valued, and since we am keeping track of some information about section, I will make it composite. So, using a composite multi-valued attribute called section, I can attach it to the course. I can attach it to course and then make the section as a composite multi-valued attribute of course. Is that a good design choice? Okay, if you do that, if you do it, then recall that attributes do not participate in relationships. Attributes do not participate in relationships. So, the section becomes a multi-valued attribute, then it cannot participate in so what about enrolls, and then what about teacher and teaching that relationship and all that, it becomes difficult to model those things now. So, So, it all again depends. So, if that particular entity is that information is required for other things like relationships and all that, so it is best modeled as a weak entity. Otherwise, you could even go ahead with modeling it as a composite multi-valued attribute. Okay. For example, email address could be modeled as a composite multi-valued attribute, multi-valued because it has user ID and domain name, and multi-valued because it has when typically person has multiple email IDs. Okay. I mean just you can also think about some other examples like that. So, in general, if a thing, even though not of independent existence, participates in other relationships on its own like our section did, it is best captured as a weak entity. Okay. If this is not the case, then you can go ahead and model it as a composite multi-valued attribute. So, it all depends on the domain which we are modeling and the usage of this information in the domain, and based on that we have to make all these design choices. Okay. Now, finally, to kind of wrap up this module, we have will spend a small amount of time on what are called ternary relationships. Often the kind of relationships that we encounter in modeling are frequently the binary kind of relationships, but occasionally we do have to make use of n-ary relationships. So, here is an example of a ternary relationship. This example is from El-Masri Navate's Fundamentals of Database Systems book. So, basically what we are seeing here is that there is a relationship called supply, okay, and that has three entities participating in it: the company, project and a component. And we have also thrown in the corresponding binary, there are certain binary relationships also we can bring into picture, like okay, let me example okay, so a company can supply a particular component. So, we want to capture that binary relationship, and a project is some activity and a project uses a component. If the component is used in the project, then we have this binary relationship called project uses component. And if a company is supplying some component to a particular project, then we call that as company serves the project. Okay. So, that is a binary relationship between company and project. If it is supplying some component to the project, then we call it company serves the project. So, these are the familiar binary relationships. Here is a supply relationship where the instance CPJ in supply basically indicates that the company C supplies a component P that is made use of by the project J. Okay. It is all the three things are associated together is what is captured by the supply. Okay. So, if you want to capture this particular situation, we need a ternary relationship. Now, if a tuple like this CPJ exists in the supply ternary relationship, then in some sense it should be obvious to you saying that the CP would exist in can supply, C supplies component P, CP would exist in can supply, and then PJ would exist in JP would exist in project uses the component, J is the project, P is the component, so JP exists in component, and in a similar way CP exists in company Cj would exist in SERS. So, the corresponding entities like this. So, the presence of Cpj would imply the presence of certain things here in the binary relationships, but the other way around may not always be true. So, supposing we have Cp in CAN supply, and Jp in users and Cj in SERS may not together actually imply that Cpj is in supply. Okay. So, this kind of illustrates that the having the 3 binary relationships is not a replacement for having the ternary relationship. You sometimes need to have the ternary relationships, because see the moment you just say let us say Cp, Jp and Cj exist, then that does not really imply that the company C supplies component P and J uses that particular component, it does not imply that, think about it. So, the binary relationships together do not convey the same meaning as supply, and so when we are dealing with n-ary relationships, ternary and in general n-ary relationships, we will have to pay attention to what are the domain details, and then appropriately capture the we may want to make a design choice whether the binary relationships are enough or you necessarily have to go for the n-ary relationship. Okay. So, there are some more interesting considerations to be thought through when we are using n-ary relationships. Okay.